Hello and welcome to our first live Q&A Ask the Basics, where we'll go over some of our most commonly asked questions by new users of nTopology. My name is Sunatasha Singhara. I am an associate onboarding engineer at nTopology, and I will be moderating our Q&A session today. And I have here with me our senior onboarding engineer, Mandy Rosengren, who will be answering all of your questions and giving you some NTOP tips that I'm sure will be very useful for many of you. To start off, we have prepared some questions in advance and have categorized them into the three topics that in these next slide. These three topics: geometry, conversions, modeling and basic operations, as well as troubleshooting. These will be the types of questions that you will typically be able to quickly find the answer to in the Help Center, which is our support site, or by contacting our support team. So at any point after this Q&A, if you have any questions of similar nature come up during your NTOP learning, feel free to check out those resources. And a lot of these content that we're going to be covering, these topics, are covered in our NTOP Core, Meshing, and Lattices courses in the nTopology Learning Center. So to find out more details, go and check those courses out as well. We'll go ahead and get started. And as we go along, please feel free to pop any questions that you have into the Q&A. Otherwise, we'll also leave some time in the latter half of the session for any additional questions as well. So the first question in the geometry conversions category, Mandy, that I have for you is, why can't I see my CAD part after importing?
Yep, that's a good question. I'll open up a new instance of NTOP to walk through why this might be the case. And this definitely is a typical question we get from new users. So let me import a CAD part into my notebook. And actually, in this instance, I was able to see this, but if I, for some reason, don't see it in some way, a part of this reason might be, one, double checking that you have that visibility on. So if you just brought that in, the visibility should be on. Then also what you can do is go to View and look at our display grid. So sometimes if you're really zoomed into that display grid and your CAD part is not centered at that origin, we won't see that immediately. And so a way to be able to find your part if you don't see it right away is to click onto that block you want to visualize and zoom into. You can go to View and then choose Zoom to Selected or use our hotkey Z. So now I can see this bracket that I brought in. So that's one way that you can check as well with that. Any other questions?
Great. The next question is also related to CAD. Why won't my CAD part be accepted in the implicit body from CAD block?
Yep. So if we go to our Utilities tab where we can find that block under Conversions, we'll go to our implicit body from CAD body, or we could also search in our search bar. And if we see here this input for our CAD body, so if we go into our block details under information, we can see that this input type only accepts a CAD body, while our import part block, which might be the block that some of these customers might be trying to use, if we go to our block details, this is actually a part type as opposed to a CAD body. And if we go into the properties, we can see that there are bodies within this part. And so when you're importing a part, often, like in this example, we have more than one body. So if we try to bring in that import part implicit body from CAD body, this won't work because it's just, they don't connect with those same type. So in order to actually convert this to an implicit body, I can go to those properties and drag and drop that body so that I now have this implicit body, and it's only going to be for that one body. Or what I can do is also double click on that import part that I am looking at, and that will select an entire CAD body. And I can right click and either create that CAD body variable and drop it into this block, or immediately convert it to an implicit body as well too.
And Mandy, could you maybe explain a little bit of the differences between mesh and CAD and implicit body? Why would you use each and when?
Yep, definitely. So if we're looking at something like our implicit body, this is going to have a field and equation represented by this. And you can learn a little bit more about that too in our intro to core, our core course on the Learning Center, as well as our intro to field-driven design on the Learning Center. But to give a little information as well. So with this implicit body, if I wanted to view that field that represents this, I can right click and choose Field Viewer or Type F. And we're going to see just this field on this plane, but it's going to be infinite throughout space. And if I turn off that visibility of my part, what we can see is our field. And if I probe my values, anywhere inside my part is going to be negative, anywhere outside is going to be positive. So our CAD bodies or our boundary representation, our BREP, that's only going to really give us that information on those surfaces, while our implicit body is going to allow us to trim lattice bodies, to do some Boolean intersects, add a lattice to an entire region, run those simulations, a lot of different options that we can have. And with this, we can also do field-driven design. So if I add a contour interval of 5 millimeters, for instance, we're going to have those values that are going to show how far away we are from a surface of a part. So you can use this to define where you're going to have a varying thickness, for instance. If you want something to change 12 millimeters away from the part, as well as 60 millimeters away from the part, it's really easy to do that with our field-driven design and with these implicit bodies. And again, having that negative only on the inside, positive on the outside, and 0 at the surface, there's a lot that we can do with that equation with that field. And it tends to be pretty quick as well to implement these different designs. With something like a CAD part, we have the opportunity to select a specific face. So if you are working with simulation and you want to, for instance, have a force just on one face, having those CAD faces can be really helpful, especially because we have some of our boundary options, such as FE face boundary. So you can use those CAD faces. Also, if you are working on a lattice and you want to add texture to a part, maybe to only a surface or a couple surfaces, that's where CAD bodies can be really helpful, because we can add that directly onto that surface using some of our blocks, such as that cell map on CAD face or between CAD faces. And also, if you're working on textures, especially on multiple CAD faces or with a mesh, that's where we would really want to use that mesh. We can create a cell map on that quad mesh for those textures. We also have latticing options that take in a surface mesh or a volume mesh. And of course, sometimes with exporting, we'll need to export as a mesh. With simulation, we'll need a volume mesh. So all of those different types of geometry types are going to be useful with an NTOP. It just depends on what type of process you're going through.
Great, thanks for that great explanation. We're going to now move on to the modeling and basic operations. These next few questions are going to be about this topic. So the first one I have in this category is, how do we define at a different corner of a box, for example, only just using min point or max point, and kind of grab those properties?
Yep, definitely. So for all of our parts, not just any box, if we go into our block details and under properties, we have this bounding box, and I'll drag and drop this. So if this is a box, we would have it take up the same amount of space as this bounding box, for instance. And if we look at those bounding box properties, we can select the centroid, the max point, and the min point. But let's say, let me bring up that box as you were talking about. And I'll also rename this section as geometry conversions and make a new section for our modeling and basic operations. So let me grab that box and drag that in there. So if we're looking at something like our box, and In that instance, I just did that zoom to selected so I could see it. If we wanted to select something other than this max point or min point, so I can drag and move these max points and min points to our notebook, and I can visualize what that max point is, what that min point is. But if I wanted to grab any other corner, what we can do is just use our math tab and use those configurations. So instead, when we would grab a point, we can, one, just choose those options for the X, Y, and Z. So instead of just taking that max point and min point, we can see if we open up that block with that triangle, we have those values in the X, Y, and Z. So I can have the max point in the X, max point in the Y, but then choose the midpoint or the minimum point in the Z. So then I get something like this. I could also use math equations, like I was saying before. So if we wanted to have only a third, we want it to be 1/3 of that distance, we could control that as well. We could use all of those types of equations. So for instance, let me grab another point to show this option. And if I wanted this to be a half of the way, we could use that centroid. If we wanted it a third of the way from this, what I can do is go to our math tab and choose that divide block or type that right in. And I'm going to choose our max point X, and I'm going to divide it by 3, for instance. And now I can bring this into my notebook. Originally, I was not able to immediately drag it in just because of that input type, because it started off as a scalar field as opposed to a scalar. But as soon as I was able to put in that max point X, it switched to the scalar option. And now if I bring in that max point and that min point, now we can see that it's going to be 1/3 of the way of that line. So you can use these math properties. You can use our points to define those different areas. And this is especially helpful when you're thinking about automating a workflow.
Okay, the next question is, how do I trim or smoothen out something like edges or corner?
Yeah, so there's a couple ways that we can go about that. So let me make this box a variable by right-clicking and choosing Make Variable, labeling this box. And for this box, if you're making something within NTOP and you want it to be a bit rounded in some way, one thing that you could do is use our offset body block. And if we put this into the body, if you are making something like this, you also have to think about that offset. But if I do an offset of, let's say, 1 millimeter, we can see that now this geometry is going to be rounded. So that's one option. If you are creating something with this implicit body, you want every area to be rounded. Another option that we can use is a smoothen body block. We can also smoothen a field or a voxel grid. So we'll put in this body. You can control that grid size, and you can choose interpolation type to be linear or cubic. So we can see it's starting to round here. And if I made this a smaller grid size, you can see what that looks like, and you can change those smooth iterations as well. And the other option, so for instance, if you are working with maybe multiple bodies and you want to have that smooth transition. So let me grab a sphere, for instance, and I'll just place it right at that 0.0. And if I wanted to have these two to be combined, so that box and that sphere, and I want this line, this area to be smoothened, what I can do is a Boolean union of that box and that sphere, and just use our blend radius, say of 2 millimeters. So now we're going to have this rounded option. You could also choose continuous as well. A couple other options as well for that. So our Boolean union, subtract, and our Boolean intersect all have that blend radius option. So depending on what you're doing, you might need to use one or the other, and you can always use that blend radius or that smoothen body or offset body.
Can you use something like this on a lattice body as well?
Yep. So if we have our lattice let's show our lattice body. So if I was going to, or let's just use our quick volume lattice. So I'll bring in this box. Unit type is, let's do our body-centered cubic, fill type all touching. So now it's going outside of this part, and I'm just going to do a thickened body to take this volume lattice and just thicken it by, let's say, 1 millimeter. So now I have this part, and a couple ways that I can make this so it's within my box. I can do in our lattice utilities, we can choose our trim lattice. If you're working with our beta tab, you can choose trim lattice body. And I can trim this, or I could use a Boolean intersect. So if I use a trim lattice, I won't be able to use that blend radius. So if I do a Boolean intersect, and I intersect this thickened body and our box, we can see how this looks. And I can also add that blend radius as well too. So now we're seeing that at those edges, instead of it being that sharp ending, we're now going to get that blend radius that we have here. And we can, again, choose continuous. We can play around with those different options, and it's going to be a bit more pointed. If I was connecting this to something like that sphere that I had before. So I will right click and make this sphere a variable, just so we have that at the top of our notebook. And I did another Boolean, or I'll use that same Boolean union block, but instead of the box, I'll choose this Boolean intersect I'm working with. And I'll make this blend radius back to 0. And I'll make this a variable and label this lattice. And place this in here. When we view it, we can see that now it's starting to blend into this part. So especially if you're doing a shell and then an infill of a lattice structure, we recommend having some type of blend radius just to strengthen that connection point between the two. So we can see that it's starting to have that rounding in between these two, as opposed to a sharp stopping point. So that'll just help with that connection if you do have some type of blend radius.
Great. Now, Mandy, do you have some tips for if somebody is having trouble orienting the objects that they have imported, for example, from CAD in NTOP?
Yep. So I guess I'll go back to our geometry conversions just to show this part. So let's say I brought this in and then I was having some trouble orienting the object. So sometimes we see customers bringing in maybe multiple CAD bodies, for instance, and multiple CAD parts. So if you were having trouble and you brought in this inner body and this outer body separately, and you're having trouble orienting them, again, you could use those body properties. So with that bounding box, moving it in those certain ways. But also, if you are working with multiple CAD parts, we recommend inputting this as importing that part, such as a parasolid, something already split up, but as one file so that they will remain connected. If you still want to move this part, there's a couple ways that we can go about it. So we do have our translate object, where you can just put in either that import part if you wanted to move the entire item, or just this one area of your part, that one body. And then you can put in a vector for how much you want to move this over. We also have, you can use for our create tab, we do have options. So in that center point, you can move this like so using the gimbal. We can rotate that object. So if you're bringing in an import part, you can choose rotate Y to Z, and that will change everything that connects with it. So that downstream that uses that part. We can also use our rotate object as well if you wanted to rotate it around a specific center, the axis that you want to rotate around, and the angle. And let me show that as well. So if I grab that implicit body, let's do that rotation center. This is where I will use that center of that bounding box. So under block details, under bounding box, I'll choose the centroid. And I'll just have this rotate along the Z or around the Z. And let's do 45 degrees. So now we can see this part is rotated. That's another way we can go about it. And then we also have this orient object block, which I like to use as well. And you can find this in our additive manufacturing tab. So we have that orient object as well as orient body on build plane if you're using this for that purpose. And what we can do is just bring in that import part, for instance, or that implicit body. I'll use the import part. And we'll just say, where is our source plane? So I'll use a plane from normal. So this is going to be that reference for how we're going to basically move this part. So where it's going to match up with this other plane. So I'm going to place this again at that center of our part. So with our import part, I can go to that bounding box, grab that centroid, place that in the origin. So that's going to be where it's located. And our destination would be another plane from normal. And we can see that the plane from normal is just at that origin. So it's just moved it from this first plane and then matched up where the second plane is. It's placing it on the same exact way as it was with the source plane. And you can also change the orientation of this block as well. So if we wanted to change that normal, instead of 0, 1, 0, 0, 1, we can do 0, 1, 0. So now we can see it's rotated and moved. And this can be really helpful with creating some type of texture or perforations. And the last thing that I'll mention, we have a lot of ways to do things within NTOP, is I also have this custom block that you can get in our Intro to Automation course. And we'll also have this that you can download in after this session, which is our custom block to move object. And this is really just taking this orient object process where I can start, let's say, with this translated object. So that's the object I'm working with. And I can just move where I want that new location to be. And I can change that rotation angle. Let's make this 90 degrees, for instance. And it will do all of that process. And it's a bit easier to just drag and move that to wherever you want it to go. So a lot of ways to do the same process.
Is there a way to split an implicit body when it contains many different connected solids?
Mm-hmm. Great question. So let me go back to this box, for instance. And for this example, I'll grab a lattice and our walled TPMS because sometimes, depending on how you design this, it might have some kind of floating areas of your part if you were just exporting this box. So if I put in this box, let's make this cell size 5 by 5 by 5, approximate thickness, let's do 1, and a gyroid. So we can see I have this little floating piece here, and if I wanted to print that, I wouldn't want those two areas. And this also could be if you have maybe another type of body that has these floating areas in it. Maybe you're importing something, and when you convert it to an implicit body, this occurs. But this is just my one example that I have. And the best way to go about this, I would suggest, is to use our split mesh option. So we would have to convert this first to a mesh. So let me grab our mesh from implicit body. And I'll make this a variable and label this TPMS. For our body, it'll be that TPMS. I'll just do a tolerance of 0.5. And one thing we can see here is that I don't have that sharpen feature on, and I have a quite of a bit of a large tolerance. And so that part that I had that was floating is already gone. So sometimes if you're meshing, depending on that tolerance, you might not even need to do any other steps further. Let me increase this cell size, and let me also increase or decrease this tolerance to 0.1. Let's see if we have that here. Let's also choose sharpen. And the next step that we would do if this did not remove that kind of floating piece Let me also try, so we're still cleaning it up. So this is a pretty good process for if you are doing something like this. But maybe if we have our TPMS instead, grab that box. Let's do that cell size 10 and gyroid. Let's see, sorry, 1 second. Well, another way that I can just show this example is I'm just going to do a Boolean subtract and just split this into 2 pieces. So I'll do a Boolean subtract and I'll just take this TPMS and I'm just going to do a box from corners so that I can drag and change this location of the 2 corners. So I have this one and this one moved. And if I look at my Boolean subtract, I now have these 2 bodies. So these are going to be a bit larger. They're not just going to be taken away when I do that mesh from implicit body. So if I see that, now I have these 2 parts, but it still considers it as one. So if I wanted to split this up into 2 separate ways, one thing that we could do, so we could decide to do some Boolean operations if you wanted to stay in that implicit realm, and I'll show that in a minute. But another option that we can do is use our split mesh block. So what this will do is you bring in a mesh from implicit body, whatever mesh you're working with. And if you go into our information, it will split any of the meshes to anything that's connected. So these 2 are not connected. And so now we have 2 meshes as opposed to just 1. And you could take this out, you can convert it back into an implicit body, and you have those 2 separate meshes. So that's one way we can go about it. The other option is again using those Boolean operations. So I use that to just create these 2 separated parts. But another way that I could go about this is I'm going to duplicate this Boolean subtract. And instead of using a box from corners, what I can use is a plane from normal, for instance. And if I view this, it's just shows the second half. So I could use our 2 split parts, for instance, if it's pretty easily to use a box from corners or a plane to remove one then the other. Make this a variable and label this split implicit. I can put this in as our primary body. And now we're just going to have that one. And I could add I could have another plane from normal and another Boolean subtract that instead of 1 is -1. So that'll only have those other options. So it depends on how kind of complex that split is, but you can use Boolean operations to remove them, as well as our split mesh and converting it to a mesh.
Great, a lot of options there. So we will now move on to the next section, which is going to be answering some questions around troubleshooting whenever you get error messages or something's not working right. And so our first question is, why won't my variable be accepted in an input?
Yep, so that's a good question. That actually happened to me earlier today. So let me add another section called troubleshooting. And I also note that someone posted something in the Q&A as well too. So we'll get to that in a little bit as well after this section. So for our troubleshooting, let's get an example such as our, let's grab just a sphere. So if I have something like this radius, for instance, and maybe I have a scalar variable. If I'm working with something like this, and let's say I want this to be 3 millimeters. So if I try to place this in, I'm going to get this error. So one of the options that might be the reason you're getting this error is because we don't have units defined in that, that variable that we're working with. So in order for this to not cause an error, I would have to put in 3 millimeters, for instance, or 3 inches. So that's one issue to think about, is making sure that you have the proper units. The other option that you can also just be careful of is maybe you're working with something, specifically if we're working with maybe that thickened body, or if we go to our beta tab. and our periodic lattice body. So if I make this a variable, or I make something else a variable, and it's a scalar field, so if I grab this and make it a scalar field as opposed to a scalar value, I'm not going to be able to add it to that input as well. So the same issue that we had with that import part and implicit body from CAD body, you always want to make sure that the input that you're bringing in can be an option for something like that. And sometimes we have blocks that can convert to multiple options. So for any scalar field, we can often convert it to a spatial 3D, implicit body, or temperature field. But with our radius sphere, neither of those are options that we can in place. They can only be a scalar. So even though we have the scalar value of 3 millimeters, because this unit type, because this type for our block is a scalar field, we can't place it in. So you would have to click on that icon and just change it from scalar field to scalar. And the same thing might happen with a list versus not a list as well too.
And there's another question on importing custom block, and what do you do if you get an error when importing one?
Yep, definitely. So if we go back to my slides, I actually have that error shown here. So it says usually not a valid custom block, output might be absent or missing input. So that might be a typical problem that we tend to see. So if I was going to import this notebook, for instance, into another to create a custom block, I would have a couple issues because if we look at let's go to our simulation tab, and we have these are our design analysis, and we have some sample materials. And if we look at these are our toolkits. If you have these double lines in here, we can right click and see that we can export this block. We can see what's happening kind of under the hood of that block and how it's created. But note that unlike our sphere, we have no inputs that we would place in for this. This is just our aluminum. This is just our materials for our general aluminum that we can use for a simulation. So it's all right to not have inputs in your custom block that you're working with, but you always must have an output. So often if you're getting some type of error, it might be because you don't have an output, or the way that your inputs and your notebook works is that it doesn't end up resulting in an actual output that you can have. So be careful with that. And that's why I always like to recommend when you're creating a custom block to save the original workflow as is before you start changing it to create a custom block. So if you do run into some type of issue and need to go back and change it again, you have that working file that you had before you started changing it to be a custom block.
Okay, so we have just one more question under this troubleshooting category, and then we'll get to all the questions that has rolled in so far. So this last question on troubleshooting is, my part looks strange, and so if that happens, what do you do if it doesn't look right?
Yeah, so that could be, a different number of areas. One thing that I'll note, so right now I'm viewing this in low resolution, which we can see at the bottom right of my screen. So if I took, for instance, this is implicit body, or let's grab this other one, and let me add our TPMS, our walled TPMS to it, and just make this a gyroid. So if I view it, we can see it looks a little funky. And the reason for this is because I'm in low resolution. This is a pretty large part. If I increase this cell size, and we have that approximate thickness, it looks even more difficult to see because we have such a large part, or large cell size and small thickness in this low resolution. That doesn't mean that our part is has a problem. We can see, again, I'm just increasing this to 1 millimeter, and we still see some of these interesting triangles. So one way that you can kind of double check that your part is as you expect it to look is you can switch from low to a higher resolution. So already we can see that this is looking a lot better. And if I looked at the bottom left of my screen, that's showing how long it takes to run. So with our highest resolution, it will take a little bit longer to run because you're going through everything in that highest resolution. Another way that we can just do a kind of sanity check to make sure that this is looking as we expect it to be what I like to do is select the block that I want to double check, visualize, or maybe you're taking a picture of this to send to a colleague. You can go to view. And then as well as that highest resolution, we have this precise render. So even if the highest resolution maybe shows some issues, our precise render is an even better check. And what this does is it'll just be a screenshot at that precise rendering to indicate what this looks like. So now we can see, and even in the highest resolution, there might have been a few of those kind of little triangles. We can see here now that it's quite sharp. It doesn't have any holes going through it. So it really was just how we had that resolution as well. Another option that might be an issue. So let's say I have a ramp or a scalar field that I'm working with. So let me grab a scalar field variable. And for this, I'm just going to make use X as our scalar field. So that X-axis as our option. And if I type F, and let's isolate I just made that issue, but basically if we type F, and let's rotate this to be 100. There we go. This is going to be our scalar field. But with something like the x-axis, we're not going to have an enclosed negative domain. So any of our scalar bodies have an enclosed enclosed negative domain, and that's how we're able to visualize them by clicking on that visibility. Like that implicit body that I showed earlier, it only has that negative field inside of our part. But if I tried to visualize something like this, so let me have that walled TPMS still on, and I try to turn on this visibility instead of that field viewer, what we can see is it no longer appears, and as I move my screen, it starts to change kind of into this interesting color. And so the reason for that is you're trying to visualize something that is infinite, has that infinite negative domain. So just be careful also when you're working with fields. That could be another issue as well.
Awesome. All right, let's now take some of those questions that we have had rolling in. The first one, someone asked that sometimes when they're importing a CAD body, they see a warning that there is a fault or several kind of faults. How can you get a little bit more info about that, and when are those usually occurring?
Yeah, that's a good question. So when we are working with NTOP, especially thinking about how your CAD body is going to be prepared and prepping this into NTOP is really important. So for instance, for something like this, when I have my CAD, I have the split already as my inner body that I might add a lattice and my outer body that I would connect to it. So doing that CAD prep ahead of time before you bring it into NTOP is going to be really key to help with those issues. Same with a mesh. So sometimes customers have some issues where they bring in a mesh that's not clean, and that can result in also some issues with your implicit body. So that can sometimes be the case. We can do some areas to kind of clean that up. But for the most part, trying to bring in something that's clean already within NTOP is going to be very helpful. So with something like that warning, if sometimes you can also, depending on what that issue might be, you can just continue going. So it is just a warning, is not necessarily an error. So depending on where in that CAD body is an issue, you might be okay. So sometimes also when we're bringing in assemblies, we can get some type of warning that things have just some areas have collapsed a little bit to connect them. So just making sure you maybe bring those all in individually if you're bringing in multiple parts and get some type of issue. However, again, if there doesn't seem to be a problem downstream as you're creating that implicit body, that should be all right as well. If you are getting more issues with that CAD body or with a mesh as well, there are a couple ways that we can go about fixing it. So the way that our mesh from implicit body works is the way to kind of have a nice clean mesh out of this is we actually go from a mesh to a voxel grid and then to an implicit body. So our voxel grid can definitely help sometimes clean a mesh or a CAD body for working with it. So we can't grab if we go voxel grid, We can't do a voxel grid from a CAD body, so you'd have to convert that either to an implicit body or a mesh. But especially if you're starting with a mesh, you can do a voxel grid from mesh and place in that unclean mesh that you have and define that voxel size. And then if you want to keep it as a mesh, if you want to make it an implicit body, then you can do implicit body from voxel grid, or you can do a mesh from voxel grid if you wanted to keep it as a mesh. And so just going through this process, we'll usually clean that up by using that voxel size. It'll just, it'll increase that tolerance a little bit, but it'll remove some of those features that might be causing some issues. So this voxel grid process can be really helpful, again, if you have issues with that CAD body or that voxel grid, but really focusing on that prep ahead of time and making sure you know what's bringing into NTOP and you're bringing in the best option available. It will give you the best results.
Okay, the next question that we got is, you mentioned before with one of those material properties of kind of looking under the hood. Is there a way to, see the inside or how that works with any other block or all of the blocks in NTOP?
So good question. So something like this, anytime you grab a block from our notebook, so also our lightweighting tab, a lot of these are our toolkits. And so our toolkits are these kind of custom blocks. We've taken a workflow, basically bundled it into this toolkit, and it has that double line indicating that if you did right click, you could export this block. So for instance, this aluminum, if I export this block, let's save it as, I'll just label it aluminum. And then if I went to import it, let's open that up. We can see what that would look like. Like so. So now it's going to show us all of those, any of the inputs, which in this example doesn't have any, but then we have that output. So if you're working with any of your own custom blocks that you're working with, so when I type CB, these are all the saved custom blocks that I typically work with on a day-to-day basis. And so I have those in my blocks folder and I can just search for them. So anything that has the CB, that's custom blocks that either you get from NTOP, maybe you create your own custom blocks, you can see that double line and it indicates that you can understand what's going on kind of behind the scenes. But with something like the sphere or our WALL TPMS, we can't right click and export that block. So some of our resources on our support site and our learning center talk a little bit about the behind the scenes and how these work. So for instance, our sphere, we use the equation for a sphere to create something like that. But that that entire workflow is not available just because, that is some NTOP propriety. We have that kind of a process of how we can go through those things. But any of our toolkits, you can right click. And if you're looking for more information on a specific block, how that works, our documentation as well. If you go to that question mark and you go to our documentation, this often can help you also understand how some of those blocks work as well. If you want to look at that block documentation and understand some more of those options as well as our support and our learning center.
Okay, we're at the last question, Mandy, and this is on how to calculate surface of a part.
Yeah, so that's a good question too. And we can see if you're wanting to do any weight savings, we have some of those areas too. We can check out some of our different options in our blocks. You can go through and understand that material properties, for instance. So we can do, if we search for this, if you're wondering on how to do surface area, you can just search. And we do have this for a body or a mesh. So I can just put in that body, that relative area, and we can bring in that surface area from a body and also our surface area from mesh. Well, you just bring in that mesh and it'll create that surface area. We also have our material properties, or sorry, our mass properties from body and mesh. And for these, so if you weren't looking for just the surface area, if you wanted to know the mass or the volume, center of gravity, we have all those options as well. So you can have all that. You can export that if you wanted to have that for some data. You're running through some types of experiments in NTOP. you can also use that volume and use it to drive some of your results. And we talk a little bit more about that in our Intro to Automation course as well, with that mass properties from body. While our surface area for mesh, you can use that. We also typically see in blocks such as our random points in a body, for instance, we have this point spacing, but if we have our random points in a mesh, you have to define the point count. So often we see customers using our surface area from mesh to define that point spacing. So you can use that surface area from mesh to determine how far away they're put apart and then get that point count. So a really helpful block as well.
All right, and so that was it, Mandy. That was all the questions we had. And so thank you, Mandy, for answering all of those. Hopefully everybody found this helpful, and thank you for joining us today. We will be hosting these Q&As monthly going forward, so please stay tuned for those in the new year. And I hope everyone has a great day.
Great, thank you.